This conference will now be recorded.
See, awesome. Thank you so much. So guys, this particular session is VXLAN, which stands for Virtual Extensible Local Area Network. Prior to starting this particular technology, which is of course an encapsulation technology, which is of course an overlay technology, I would like to tell you the significance of this particular technology. Today in the world, everybody is, talking about what? Everybody is talking about software defined networking in data center. Everybody is talking about software defined access. Everybody is talking about software defined wide area networking, SD-WAN. What does this mean? This means everybody is talking about taking us to the cloud technology. Now, VXLAN, we can say, is the prerequisite understanding for the purpose of learning and configuring SDN, which stands for software defined networking, which is nothing but our data center technology. Now, post VXLAN completion, our next topic is Cisco ACI, Cisco Application Centric Infrastructure, which is nothing but Cisco's version of software defined networking. It is not only that Cisco is there in the industry, there are a lot many other vendors who are providing software defined networking solution, VMware, Arista Networks, etc. Now over here, I would like to point you guys out. Apart from Cisco ACI, I would like to point you guys out to another competitor, a wonderful, beautiful competitor of Cisco called Arista. Arista has given us the solution, software defined networking solution by the name of Cloud Vision. Now, Cloud Vision says, if you really want to configure the software defined networking, the prerequisite in terms of configuration is to configure VXLAN. Cisco ACI also says that I do need VXLAN, but this VXLAN, I will do it myself. So it gets auto configured in Cisco ACI. But Arista Network says, why don't you start your configuration from the scratch? From the scratch in terms of racking and stacking, in terms of cabling, racking, starting from racking and stacking, then cabling, then connect cabling, after cabling, IP connectivity, and then underlay, and then please do configure VXLAN. Yes, we do racking and stacking, cabling, IP connectivity, no in ACI. Underlay configuration, no in Cisco ACI. VXLAN configuration, no in ACI. Why? Because ACI does all these things in a very automated fashion. Well, I will tell you how this is done in automated fashion. But in case if we are not going for Cisco ACI solution, but we are going for other vendor solution, don't you think it is pretty important for us to understand, take a deep dive and to understand this technology called virtual extensible local area network, right? And the answer is truly yes. So this session, all right, and the session which will continue with these sessions, this session later on, will focus towards a deep dive understanding of what is virtual extensible local area networking, What are various terminologies? What is the architecture? How to configure it? And before configuration, what are various underlays? So guys, there is a prerequisite expected from you guys, right? Before I continue with this VXLAN next week, the prerequisite which you please fulfill for yourself is to understand OSPF and to understand BGP. I know that you do understand, but please do brush up your knowledge with regards to OSPF, with regards to BGP, and in BGP, a little advanced part of BGP known as MP-BGP. What I will do is, once you are comfortable with BGP, and then I will make you comfortable with regards to MP-BGP by adding up one specific address family called EVPN. Right? So apparently, you know what I'm doing? I'm just trying to tell you the prerequisite before understanding the VXLAN. I know that OSPF and BGP, all you have done. One more thing, you know, which I would consider as a prerequisite understanding for you is to know about multicast. Keeping myself in your shoes, I do understand multicast is something not everyone's cup of tea, because we hardly get an opportunity to configure multicast. But multicast being very important in VXLAN, you know what? We will dedicate our 1 hour at least to understand what is multicast, to brush our knowledge with regards to multicast, right? So one day I'll give a pause on VXLAN after having just the theoretical understanding. Before moving over to the configuration of VXLAN, we will pause for the purpose of multicast. All right. This is what we are talking about is VXLAN on day 0, which we call it as intro. And please take this session as your question and answer session. More you will ask your question, I will be able to give more details. And probably I need to welcome a couple of friends of mine who have just and recently joined. And here I welcome Akhilesh and Eduardo and Mohit and Saroj already. Shamim, thank you so much for joining, though you joined a little late, no worries. And Swapnil, thank you so much, guys, for joining.
Yeah, thank you, Rashish.
Thank you, Mohit. All right. So, guys, VXLAN intro, and you're welcome. Intro and importance of VXLAN I have communicated. So let's begin with the agenda. What we are going to discuss, the very first thing, what we are going to discuss with regards to VXLAN is to understand VXLAN topology. And you know what? This reminds me of one LinkedIn survey question which I put today. Every day now you will see till the VXLAN is going on, you will happen to see one LinkedIn question every day in my LinkedIn account. Please try to answer them. Next day, I will give you answer to the previous day question, right? And it will come up with a new question. So this is going to be a good kind of revision for us. So please do join me in my LinkedIn account. And where is my LinkedIn account? Let me show you. And here my LinkedIn account is, okay. And this is me on LinkedIn. Please do look at into the daily question which I will be putting in my LinkedIn account. And my today's question in LinkedIn was about what is the name of the architecture followed in VXLAN, and 62% of the people have given the answer fabric path. 33% of you people have answered close network. Erwin architecture 2%. Cloud vision is 3%. And can anyone say what is the right answer?
Class network.
Absolutely. The correct answer is closed network. Why is it so? Now, let me tell you the history of it. Over here, I will just give you the next day, I will just give you the right or the wrong answers, but the explanation you will be getting in the session. So the agenda, first agenda is going to understand what is VXLAN topology, followed by the underlay versus overlay, understanding overlay based data center VXLAN and its evolution, various terminologies, VXLAN deployment mode, and this last, which is not the least, this last is the star, 5-star bullet point, which is nothing but which is going to take us to the configuration. Okay, well, this particular part called terminologies, we will be addressing various VXLAN terminologies over here. By the moment you'll come to this particular bullet point, you know what? All the terminologies we will discuss in advance. So first thing first, VXLAN, what kind of topology or the architecture it requires? VXLAN requires an architecture which was first time invented way back in the year 1938 by a gentleman called Edson Erwin. But this particular architecture was formalized by a gentleman in the year 1953. Name of the gentleman was Charles Claus. Thus, this particular architecture most commonly is known as Claus architecture. This Claus architecture was used by Bell Telephone Company. The beauty of this particular architecture is what? The beauty of this particular architecture is absolute layer 2 loop avoidance. We all know what is layer 2 loop. Why there is no layer 2 loop? The reason is simple, because this architecture do not allow you any lateral connectivity. No, sorry, spine to spine, leaf to leaf, no lateral connectivity is allowed in this architecture. You know what? Current topic going on with us is VPC, virtual port channel. There is an exception to this. There is an exception to the phenomenon when I said there is no lateral connectivity. You know what? You can do it. But you can do the lateral connectivity by creating a peer link and binding both of them in a single domain called VPC domain. We have got 2 labs in VPC to be done. In lab 1, I will not give you any lateral connectivity, but in lab 2, I will allow you to connect 2 of the leaf switches, right, laterally. Now, without telling you, I have named them as spine and leaf. Guys, in this particular architecture or in topology, well, this is not a conventional topology, not a conventional Cisco 3-tier architecture topology, wherein we do have core, then we have distribution, and then we have the access. Instead, the core and the distribution layers are merged over here in one single layer and unofficially, you can call it to be as unofficially, because this terminology is not allowed. Collapsed core. Why this terminology is not allowed? Because VXLAN is an industry standard encapsulation protocol. Core distribution and access layer architecture is Cisco proprietary. Collapsed core concept was also provided by Cisco only. So we are not authorized as per the industry terminology standard to call this as a collapse core, but for the sake of understanding, you can call it to be as collapse core. So we do have just two layers in case of VXLAN topology. The upper layer switches are known as spine switches, and lower layer switches are known as leaf switches. No east to west connectivity, only north to south connectivity allowed. In our globe, we have got in our globe, we have got two kinds of lines forming a grid, forming grids. The horizontal lines and the vertical lines. Horizontal lines are known as latitudes, and vertical imaginary lines are known as longitudes. If you want to call them, we don't have latitudes, latitudinal connectivity. We have only longitudinal connectivity in case of our VXLAN. Technically, they call it as a non-blocking circuit switching network. Well, so answer to the question of the day, what is the name of the architecture followed in VXLAN, is clause architecture. Now guys, you can click the correct answer. 500 and how many people answered? 501 I saw, right? Out of 501 votes, 33% correct, means 150 people said give the correct answer. Around 300, I'm sorry guys, gave the incorrect answer. Now they probably thought the question in a different way. Fabric path is also based on the same architecture, my dear friends. For fabric path, FP, which is no more included in CCIE data center version 3.0 blueprint. It is an old Cisco technology, right? No more in use, and this technology was also based on this architecture only, given by gentleman, formalized by gentleman Charles Claus. So fabric path is not the answer, it is a Claus network which is the correct answer. All right, just trying to show you what I explained you, the connectivity type. Now, what does VXLAN require? The very first and foremost important thing, which is very common, is racking and stacking. Second is, all right, let me write down, rack and stack. Then we require cabling, and then once cabling is done, then we need IP connectivity. IP connectivity means what? IP connectivity means with regards to all the interfaces, we have to make all these interfaces as layer 3 interfaces, and we need to provide layer 3 IP addresses on these interfaces. Third thing done. Fourth important thing is to set up our underlay. When we say setting up our underlay, our expectation is to configure an underlay routing protocol. Since this is an industry standard technology, we need to use the routing protocol, which is industry standard. We know that RIP is there, EIGRP, RP, OSPF is there, BGP is also there. But out of these different routing protocols available, EIGRP predominantly Cisco. Couple of years back, Cisco said, I am formalizing it, sending it to the industry, everybody can use it. RIP is based on hop count, never a protocol, never a popular protocol. OSPF is the love of all. Industry standard, simple to configure, and based on a proper topological setup. OSPF is the routing protocol of choice in VXLAN to ensure that all the leaf and spine switches, irrespective they are directly connected or not, they should have reachability. Since VXLAN is an overlay technology, which means it helps us to create a tunnel, but for the purpose of tunneling, we require IP reachability. For the purpose of IP reachability, we require underlay using routing protocol OSPF to be configured. And you know what? When it comes to configuring Arista SDN solution called Cloud Vision, you know what? You have to do this, 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 and then finally you need to configure VXLAN as well. But when it comes to Cisco ACI SDN solution, Cisco ACI SDN solution says, don't bother about this, don't bother about this, don't bother about this, just simply go and configure this, which is not fair for us who are very inquisitive to learn. All right, so once underlay is ready, IP connectivity between all the devices is established, all the devices are able to reach, then we go for our overlay setup. All right, so this topology, what do you see over here, is all underlay. In underlay, our servers, our access devices, they are connected with the leaf switches. Leaf switches, you can call them to be as access layer switches. This segment is known as LAN segment, but now for the purpose of VXLAN, we need an enhancement. So we do an enhancement by creating VXLAN overlay. What is the meaning of this VXLAN overlay? VXLAN overlay empowers the switches which are not directly connected to each other to get connected to each other directly with the help of the tunnel, with the help of encapsulation. So with the help of VXLAN overlay, we create end-to-end tunnel between the VTAP devices. How? We will see that. Purpose, we will learn about the purpose. But you know, before going further ahead about the overlays, it is very, very important, right? Guys, be ready. This is going to be the next question in my LinkedIn. Please, oh, 1 second. Let me get and grab some water. All right. So guys, be ready. This is going to be my next question in the LinkedIn survey? I'll give you option of 4 different overlays. You have to choose the one which is incorrect. And here comes the answer. And for that, what I need to do is I literally have to zoom this picture from current 102%, to the maximum, which is 400%, and I have to bring the right overlay in front of you. The purpose, this overlay which I'm showing you right now, maximize, is called network overlay. In case of network overlay, the tunnel is being formed on which devices? Here we go. On the hardware. These are our hardware switches. And previously, in the previous slide, I wrote over here leaf. Leaf switches get configured, and we call these leaf switches as what? As VXLAN tunnel endpoints. And in short, crispy, VTAP. This is one of the terminology. So you can see that the tunnel is being formed between VTAP say 1 and VTAP say 3 over here. VTAP tunnel is being formed on VTAP device 2 and VTAP device 4 over here. When we create our overlay using our hardware leaf switches, then we call it very simple as what? We call it as, I'm sorry, I have to clear it, and then as network overlay. Okay, simple. This is what we are going to do. Another kind of overlay, which is known as host overlay. What actually do we do? Now you can see that the leaf switches, right? VTAP is not mentioned on the leaf switches. The VTAP, VXLAN tunnel endpoints, that is the devices from where we start and end the tunnels, it is moved over to, what is this? What is this? This is not a switch. This is a server. This is actually a hardware machine, which is being virtualized. By deploying an abstraction, a virtualized abstraction layer known as hypervisor. What is the concept of hypervisor? What is a virtual machine? What is the concept of virtual switch in a server? We all will discuss in our next topic called ACI, where we do have explanation of network virtualization, that is, how do we virtualize it. But here I would just like to tell you that we can virtualize our hardware server from one single hardware machine to hundreds of virtual machines. This requires a hypervisor to be installed. On top of the hypervisor, we get blessed with a virtual switch called VTAP. On the other hardware machine, we can do the same. So we have got our VTAP, that is called virtual switch. You know what? We can call it to be as a virtual standard switch or distributed virtual switch. Again, I will explain you the concept of virtual standard switch and distributed virtual switch in the topic called Cisco ACI, but these are the switches. By the virtue of VXLAN configuration, you can call them to be as your VTEP devices. So your tunnel begin and your tunnel endpoints can be your virtual endpoints. And if this is the case, then we call it as host overlay. Host overlay. What is host over here? You know what? I would like to say a big thank you to VMware for introducing, for pioneering, I should say, for pioneering the concept of virtualization, not only network, not only server, but overall virtualization. Thank you very much. Thank you very much. And just a knowledge to share with you today, I got to know about that for $61 billion, right, Broadcom is ready to buy, take over VMware, right, guys? In case if you have more knowledge, so you can share, right? But that's not the agenda. That's a good amount, $61 billion, the highest. So you can understand how big and beautiful this organization is, VMware. All right. So we have spoken about network virtualization. We just discussed about overlay, host overlays. Now let's come over to the next overlay called hybrid overlay. In case of hybrid overlay, it is a mixture of, it's a combination of network overlay and host overlay. That means on one side, my pen, you may have your VTAP on the virtual switch. On the other side, you may have your VXLAN tunnel endpoint on the hardware switch. It is indeed possible a combination of physical and a virtual endpoints can create our VXLAN tunnel. Guys, this is going to be the most advanced case in case if someone wants to set up this kind of. So I will say this is the most beautiful, one of the most beautiful technology we are going to come across. Okay, and it is. Any questions so far with regards to what basic things we have discussed so far? Just very simple and basic thing. Be normal. Any question? And let me see, in case if I need to welcome some more friends of mine over here. And all right, Akhilesh, you have just joined. Thank you so much and welcome. And hey, Ruben, nice to see you back again. Good. Yes. Sonali, welcome to you. Thank you so much. And Umair, is it Umair, my dear friend from Pakistan?
Yes, Ashi.
Hey, Umair, nice to have you here after so long, after so many months. Good to have you. Okay, wonderful. So guys, this is just an introduction of our dear VXLAN, which is nothing but which is an overlay. I would appreciate you guys to please do comment on the question which I do put, and I really appreciate those friends of mine who have entered into a very good communication and discussion about VXLAN. So guys, this is the way, an interesting way to learn a technology. So this friend of mine, Jeff Tansura, he said VXLAN is an encapsulation, not an architecture. And I have answered him. You please address the concern. Ashish Haldar has given a beautiful statement. I think VXLAN is a fabric, as fabric means both underlay and overlay. VXLAN works on top of underlay. Am I right? And I have answered him, yes, VXLAN needs underlay. Before giving the final answer, I'm not supposed to give the comments which can help them to get the answer. A beautiful comment being added by Edwin Sutherland, dual CCI. Clause fabric is the topology often used for deploying a VXLAN based overlay network. Why? Here he answers. Number one, entropy to maximize use of all links between leaf and spines. Number two, predictive latency with 2 hops between any leaf to leaf communication. Guys, very technical terms he's using. I appreciate him for this. Predictive latency, very important terminology. Simplified scaling, scalable with bandwidth, with more spines, scale host attachment with more leaf. Guys, would appreciate you to contribute to these comments, and these comments will enhance your learning and knowledge of the technology. I will make sure, I promise you, every day I'll keep on putting the questions. Please comment. It will not take much time of yours, but it will enhance and it will help you to solidify your knowledge about the technology. So back again to data center overlay edge devices. Overlay, tunnel, encapsulation. Now, introduction of certain terminologies. VTAP, VXLAN tunnel endpoints, LAN segment, virtual server, physical server, and you know when we talk about overlay, this VLAN segment gets changed to VXLAN segment. You will see during the course of the configuration, we have the VLAN over here, VLAN ID, but we will encapsulate VLAN ID with another ID called VNID called VXLAN network identifier. You will see the beauty of encapsulating the original 802.1q frame with our VXLAN headers, and we will be calling it as VXLAN segment. Why? Because an ID of say 100 will get mapped to an ID of 10100, for example, right? Anyway, that's we are going to discuss in detail, in depth in our configuration. So VXLAN provides us the tunnel encapsulation. Now, VXLAN, various definitions to understand this technology. VXLAN, first of all, virtual extensible. Extensible begins with the English alphabet E, but we give emphasis on X, right? Extra large. We don't say EX, but we say call it as XL, right? Similarly, extensible, X is given more importance, and we call this abbreviate virtual extensible local area network as VXLAN. VXLAN, we call it to be as layer 2. In layer 3, overlay tunnel, we call it as Ethernet, which is what? Ethernet is 802.1q, which is nothing but VLAN ID. In UDP, very, very important. You know, I'm definitely going to put a question to the community at large. You know, yes, thank you so much to 25k plus friends of mine in LinkedIn. Got a very big community, right? So to a community at large, to please let us know the significance of UDP in VXLAN. Guys, this question I will be putting in the day 1 session of mine to all of you people to please let us know the significance of adding a UDP header for the purpose of VXLAN. Okay, I'm just giving the brief ideas of the various topics, various terminologies, etc., and the logics, etc., which we will be studying in our forthcoming classes. Similar to OTV, overlay, transport, virtualization, this is an obsolete technology, Cisco proprietary, was in use till version 2.1 CCIE data center, now not considerably to be used, getting obsolete day by day, going to be end of life, end of support technology, but similar to have more numbers of L2 segments via multi-tenant network. My dear friends, the lab number 2, which will be for you, will give you an opportunity to configure not one single tenant but multiple tenant and to be supported by multiple VRFs. VXLAN, the beauty of VXLAN is multi-tenancy, and this requires a deep dive understanding of why do we say that VXLAN supports multi-tenant. What is the meaning of the terminology called tenant, which previously in conventional networks we used to call as customers? Dear friends, in a cloud-based data centers, in a cloud-based technology, we don't call customers as customers, but we call them as tenant. There is a reason. This can be put as a question. All right, so get ready. This I will be explaining later on. It is absolutely an open standard. No proprietary control of any of the vendor, Cisco, Arista, Huawei, VMware, Nutanix. All these vendors, they use this technology, but no control of any of the vendor. This is absolutely an industry standard technology, first presented in RFC. RFC stands for Request for Comment, white paper 7348, and then later on in RFC 7432, we will be talking about them as well. When it comes to Cisco, VXLAN is available only on certain selected devices. The high-end devices, Nexus 9K switches, Nexus 7K switches, it is available. When it comes to low-end 5K, only it is available in Nexus 5600, say 5648 or 5696 switches. 5600 switches, it is available. Not at all available in Nexus 5500 series switches. When it comes to Nexus 7000, VXLAN is available only and only if you have the F3 line card. Probably you can remember, you do remember, I told you this point as well during our Nexus hardware sessions. So VXLAN on Nexus 7000 series switches is available only and only if we have F3 line cards. And if you want to know what is F3 line card, then you have to give me time. Right, those new friends of us who were not there in our Nexus hardware sessions, probably they do have this particular doubt, and we call it as evolution of F series of line cards. Any question? No? No worries. Our window for question, doubts, comments, complaints, compliments, absolutely open. All right. VXLAN, slowly and slowly we are moving towards, the more deeper understanding of VXLAN. But it's always better to learn a new technology by establishing analogy with its previous technology. So VXLAN analogy, let's establish with the VLAN. We all know what is VLAN. What is VLAN? IEEE 8021Q standard has provided with the flexibility of segregating our layer 2 networks into small virtual networks called VLANs. And it says that we are giving you 12 bits for the purpose of creating multiple virtual local area networks, which means in total 4096 total local area networks, L2 networks you can create, you can segregate. And you know what? Human desire is unlimited desire. Our desire, as we are expanding, gets increased. So here comes VXLAN, which provides us the double the number of bits, 2 raised to the power 24, and if we expand it, we get 16,777,216 VXLAN network identifiers called VNIDs. You may be thinking what the heck it is with this gigantic number. Simple, I can say that this huge gigantic number gives us, I'm sorry to say, guys, I may be confusing you by using another complicated terminology, multi-tenancy. Again, my sincere apologies because this is a little complicated. I cannot theoretically explain you unless and until I practically show you the configuration of multi-tenancy, for which, yes, you do need to give me some time, because this multi-tenancy lab configuration will be covered in our lab number 2. Lab number 1 does talk about single tenant, but fair enough. All right, it allows multipathing. It allows L2 loop prevention. No need of spanning tree protocol because we don't have this connectivity. Right? Everybody, all of us, we know what are layer 2 loops. When we don't have this connectivity, no chance of having a layer 2 loop. Equal cost multipathing. Yes, because one device is connected to all. So we do have a flexibility, the benefit of equal cost multipathing. What exactly is this? What contributes to this? I'd like to take a pause, right? I would like to take some time to explain you what contributes to equal cost multipathing in our VXLAN, right? And this is related to one of the question which I will be putting across in advance. All right, multi-tenancy, I'm sorry, as I said earlier, this requires me to explain how do we achieve multi-tenancy. For the purpose of multi-tenancy, we have a flexibility of, you know what, approximately 17 million IDs. To be more precise, it's 16,777,216. Please do learn this beautiful number. Question. Any question from your side? Okay. Before going further ahead, I would just like to take a pause, because as we'll go further ahead, we will become more and more technical. My intention over here is to give you an introduction, just to give you an insight and to provide you a futuristic technology. Okay. I am done. I am done with regards to my day 0 explanation of VXLAN. Many things are there, but still would like to appreciate you guys if you can contribute to your questions. No worries. Then no worries. I'm going to request Madam to stop recording.